So hi guys, how are you people doing? Okay, I hope you've been watching all the videos before this. Hi Rishi, how are you? Hi Saiteja. So welcome, first of all, welcome guys to the Unacademy JEE English. This is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this channel, every concept of physics is being taught to you completely in English, so that the language is not a problem when you're trying to understand your concepts. I'm great. I'm great. Namaste to you too, Saiteja. All right. So this is a series which I host for class 11 students, and the topic that we are covering right now is work, power, and energy. And this is lecture number 4 for that series. And today we'll be talking about conservation of mechanical energy and the applications of that. Okay. So Clevis Ryan, hello. Yes, I know the advanced result is here. Some of my students did very well. So Saiteja, one book if I had to refer, so you realize cracking JEE mains in advance is not going to happen with one book. You will need some books for theory reference and a lot of books for practice. Okay, so for theory reference, if you want, I can refer you not one, two books. You can, that is personally what I recommend for anybody. So those two books are Resnick and Halliday, which is Fundamentals of Physics by Resnick and Halliday, and then you have University Physics by Young and Friedman. Okay, those are internationally reputed books. Those are books which are more than 50-year old. So and they are widely accepted, and the theory in them is perfect. These books do not contain any errors. So you can consider those books to be the Bible of physics. Okay, so if you have any confusion regarding any concept, you can refer to those books, and whatever they say can be considered to be the truth. Okay, so yes, that would be for theory. Those are wonderful books for theory. As far as your practice is concerned, I think H.C. Verma is a must. That is still, trust me, a book which I studied when I was a student, and that book has a wonderful collection of problems. Okay, good evening to you, Rishabh. So that would be one. Okay, and once you have solved those, then maybe you can talk about other books also. But in my opinion, those books are a must for theory. You need to refer to either Resnick Halliday or university physics. I don't prefer recommending any other books uh, by any Indian authors, because these are internationally reputed books. They are followed. University physics is followed in MIT course curriculum. Okay. Oh yes, that is always going to be there. Don't worry. All right. So as I said, university physics is a book that is used in MIT course curriculum. So the MIT Massachusetts Institute of Technology. So that is a book on which you can rely blindfolded. Next, of course, for problem solving, I think H.C. Verma is one of the best books. So these are a must. And then when you're done with those, then maybe you can look at other books. Okay. So before we get started, let me introduce myself for those of you who don't know me. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for the JEE exam. Now, all this teaching so far had been offline. This is the first time that I have started teaching online. I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exam that I took. So you guys right now take the JEE Mains and the JEE Advanced. Similarly, we also used to have two stages. In the first stage, I was All India rank 192, and in the second stage, I was All India rank 447. And from there, I went to IIT Delhi to study mechanical engineering. And I also qualified the NTSC Stage 2 when I was a student. I was also in top 1% in the NSEP, which you better know as the National Standard Examination for Physics or Physics Olympiad. And I've already coached many students to top ranks in the IIT JEE exam, both mains and advanced. And so far, all that results so far had been in the offline setups. This is the first time that I'm teaching online. So, because of this lockdown, all of us were forced to move online. So I thought, if I have to move online, why not get associated with the best? So here I am, courtesy Unacademy. Which do you prefer for chemistry? Okay, so So, Saiteja, the point is that when I took my JEE, it was long time back, long time back. We used to have a subjective paper, okay? So the books that I referred probably will not be of much use to you today. The pattern has changed a lot. Okay, so subjective used to require a lot more rigorous studying. So trust me, for physics also, I solved the entire Erudov when I was a student, and I solved two other books also, which were slightly more difficult than Erudov also. Right now, you guys don't need those kind of problem solving because in objective they never ask you that kind of questions. In subjective they used to. Hi Ashwin, how are you? And yes, good evening to you as well, Rishi. Okay, so as I was saying, so in this tough times, when everybody is forced to be locked down in their homes, so how do you make sure that your studies are not suffering? You can also get your unacademy subscriptions. With unacademy subscriptions, you will get benefits like live classes. You will get to interact with your educators. So your learning never stops. It continues as seamlessly as it would have in your offline classes. Now these classes also have live polls and leaderboards, which keep these classes highly interactive. You also get a test series and you have analysis sessions. So they make sure that you are always aware of your standing in the examination and always know where to improve and how to go about it. Then you also have live doubt clearing sessions, which is again very, very important because trust me, doubt solving is a huge part of your JEE prep. A lot of students are always worried because their doubts are not getting solved. Now, as a compulsion, all Unacademy courses have a doubt clearing session after every three teaching sessions. So every fourth session is a live doubt clearing session that will ensure that your doubts never get piled up. And on top of all these benefits, I think there is one additional huge benefit that is not mentioned here. That is when you're studying online. So suppose if you're studying from YouTube, so you know how YouTube works. It can be very distracting. You might want to just watch one video. You will have 50 suggestions which are based on your likings and everything. So you will get tempted. You will end up watching 5 videos maybe and end up wasting a lot of time. So when you're studying on Unacademy platform, that is never a problem because all the content there is all your study related. So there will be no distractions there. So I think that is a huge, huge advantage for all students. Okay, Rishi. Yes, I will be posting the PDFs. I don't post DPPs actually. Okay, so Sai Teja, I'm not at the liberty to disclose that. That is supposed to be a confidential information. Okay, but in any case, it shouldn't worry you too much. All right. And as I was saying, on top of all these benefits, with your Unacademy subscription, you are getting access to India's top educators. So Unacademy has gone around, found the topmost educators, and is giving you a chance to study from any of those best teachers in the JEE industry from the comfort and safety of your home. Now, how do you get the subscription? Very, very easy. First, you will need to install the Unacademy app. Once you have done that, go to the plus section in your app, select your goal as IIT JEE and click on the get subscription button. Now, when you're getting your subscriptions, do remember to use this code RD Live. This is my code. This will give you a 10% off on all your subscription fees. So the moment you apply this, you will get a 10% off on all these fees. These fees are already kept very, very reasonable and very competitive. Trust me, any offline coaching would be charging you anywhere between 4 to 8 times this fees. All right, so with Unacademy subscription, you are getting the same quality education at a very, very reasonable price. So make sure you are getting this subscription and make sure that you are getting the quality guidance that you need to crack this exam. Those of you who are following us on the JEE English channel can connect with us on the Telegram app using the link shown above. So now let's get started with today's topic without any delay. So today, this is lecture number 4 of Work, Power and Energy, and we will be talking about conservation of mechanical energy and the work energy theorem, including potential energy. So last time we had discussed about conservative forces, non-conservative forces, and we were talking about potential energy. So let's just have a quick recap. And before that, why don't we get started with a warm-up problem? So this problem is based on your concept that we discussed in the last class. Okay. So this is application of work energy theorem. Let's see how much you remember. Okay, so this question says you push a 4 kg box which is initially at rest on a horizontal table through a distance of 3 meters by a horizontal force of 25 newtons. If the coefficient of friction between the box and the table is 0.35, find A, the external work done on the block table system. Find B, the energy dissipated by friction. Find C, the final kinetic energy of the box. And find D, the speed of the box. So why don't you guys get started? Yes, absolutely, absolutely. If you pay attention, if you pay enough attention to my classes, I am discussing all the fundamentals. Wherever you have your confusions, you can ask, and I will make sure that you are getting your concepts right. And trust me, if you have strong fundamentals and if you have practiced enough, thorough practice and strong fundamentals, that is all that is needed to crack the advance. So yes, if you practice enough problems, let's say 150 problems per topic, and you listen, pay attention, close attention to all the lectures, you will be able to crack the JEE exam. Don't worry about it. Okay, so why don't you guys get started with this problem? Let's see you guys try this. I hope you guys have all seen the lecture number 3 where I talked about work energy theorem. So this is a warm-up problem helping you remember what we had talked about last time. So see, I mean, Sai, what happens is that cracking JEE is actually very, very simple. It's not that complicated. All you need to do is pay close attention to whatever your teacher is teaching. If some concept is not clear, make sure that you are asking your doubts. Second, after the class is over, make sure that you're revising it and you are solving problems. And then, if in revision you find any difficulties, then in the next class, before this class has started, always make sure that you get rid of your doubts. Okay, so you keep doing that, trust me, and do that consistently. Consistency, I think, is the biggest differentiator between successful aspirants and aspirants that don't make it. Okay, see, most of you will be preparing for 2 years for this exam. So studying consistently for at least 4 to 6 hours daily for 2 years, if you can manage that, there is no stopping you. Don't worry. Okay, okay, you can do that. So, so that is why I like to start my class with a slight revision of the previous class, and that is why I included this question to make sure that you guys are revising. Because trust me, that is it's small things like these where you guys falter. You don't revise your concepts enough. By the time you're attending the next class, you have forgotten about what was discussed in the past class. So that is why there is a disconnect, and that is where lag comes in your learning. Okay, so don't worry about it. Make sure you've watched all the lectures before, and then you can try this. So I don't know if any of you guys remember what we discussed, or most of you guys are new. I haven't seen most of you guys before today, so I don't know how many of you have watched my previous lecture. So in any case, what I'll do is I'll just go ahead and solve this so that you guys know how to approach such a problem. So let's see, what have you been asked? You have been asked that you are pushing a 4 kg box through a distance of 3 meters by a horizontal force of 25 Newton. Okay. Now let's see what has been asked. The external work done by the block on the block table system. So external work is being done by the external force of 25 Newton. This is the external force that will be doing work. How much will be the work done? Let's see. So part A, work done by external force would be, the force is 25, the displacement is 3, and the angle between the force and the displacement is 0. Hi Pawan, how are you? So would you like to try this problem? I had a small warm-up problem just to help you remember what we discussed in the last class. So why don't you give it a try? Okay, and I'll wait for you to just quickly solve this. Okay. Let me know if you want to try this, or do you want me to go ahead and solve this? All right, great. So I'll wait for it. Okay. So make sure you pick up on these small little habits, okay, guys. If you want to, crack your exam successfully, it's the small habits that make all the difference. Small habits like always revising your lecture once, after the class, the same day, and then always try at least 15 problems the same day. So that would be my advice for those of you who want to crack the JEE exam successfully. So suppose you are watching my lecture right now. It's a 1.5 hour lecture. One, you should be making your own notes, paying attention, close attention, noting everything important that I'm saying, because my slides will not have everything that I say, right? So make sure you are noting down every important bit. Next, after the lecture in the evening, just go through all your notes, or maybe watch the video in maybe 2x speed or something like that. Just quickly revise that. Once you have done that, make sure that you are solving at least 15 to 20 problems the same day, so that you can identify if there is any part of the discussion for that day that you can't understand. And if you can find those, then make sure in the next class you are getting that cleared. That should be the first thing. Hi, Joy Mosby. How are you? Okay, so 33 Newton. What is 33 Newton? What has been asked of you? See, read the question carefully. What has been asked of you? Part A is asking the external work done. So how can the answer be 33 Newton? Has to be joules. Yes, 75 joules is the correct answer, of course. That is very simple. You have been shown the direction of displacement, you have been shown the direction of force. The force and the direction of displacement are the same. So it's just F dot S would come out to be 75 only. So that is very simple. I'm starting the class with a very simple revision problem, just to help you revise things quickly. Okay, so yes, Rishi is right. 75 joules is the correct answer for part number 1. How about part number 2? What would be the energy dissipated by friction? What would be the energy dissipated by friction? Think about it. 42 joules. Okay. Okay, let's see. Yes, that seems about correct. 42 joules seems around correct. Yes. Hi, for education. How are you? So yes, you got the part B. Now part C should be very easy. Yes, that would be 33. Absolutely correct. Now that you know that, you should be able to find the speed of the box. Okay, so that is how you always solve. If the question only said that find the speed of the box, you would have done all these things. So I'm just trying to show you how to approach a problem. You can break a problem into several parts. Okay, so yes, Pawan is getting all the answers correct. So work done by external agent would have been 75 joules. Now for friction, kinetic friction, the kinetic friction would be in this direction, and it would be equal to mu mg, because as I can see here, the n would be equal to mg, right? If I draw the FBD, there is mg, there is n, and n would have to be equal to mg. So that is why I will get kinetic friction as mu mg. So I know friction is 0.35 into 4 into 10. So that is okay. So I think not 42. Not 42, I think. That will be 3.5 into 4. That is 14. 14 joules. Okay, right. Sure. Got it. So work done, yes, would be 42. You are right. Work done by friction would be minus times 14 into 3, which is minus 42 joules. Make sure to write the minus sign. That is important. Okay, Pawan? Now, obviously, the total work done would be change in kinetic energy. Delta K equals W net. That is my work energy theorem. So, initially kinetic energy was 0. Okay, it was initially at rest. So, the final kinetic energy of the box would be K final minus 0 would be equal to 75 minus 42, which is 33 joules. Now, once you know that, finding the speed is super easy. Hello Rohit, how are you? So now you can write half into 4 into v square would be equal to 33. So yes, V you would get as square root of 16.5. Yes, Pawan, that is correct. So these are all the four answers. I hope now you guys remember everything that we talked about in the previous lectures. How to find work, how to find kinetic energy, how to apply work energy theorem. All right, congratulations, KKS. Very well done. All right. So let's start with the discussion that we started last time with the potential energy. Yes, last time my pen battery had gone down, so I couldn't write much. So I thought I will just quickly talk about that one more time. Okay, so we discussed that this is the energy possessed by a body by the virtue of its position. And what did we mean by its position? It what I meant was if I change the position, I'm giving a conservative force some chance to do work. All right, and that is what I'm calling the potential energy because I am providing the conservative force a chance to do work. Chance we also call potential. If you have chance of something, then we say you have potential of something, right? So that is what we call potential energy. That is great, KKS. Many congratulations to you. So which college and which branch are you planning to go to? Okay. So till the time KKS replies, let's continue with our discussion. Every potential energy comes from a conservative force and hence is defined only for conservative forces. So whenever you talk about potential energies are only defined for conservative forces. You can have one potential energy corresponding to one conservative force. So now, as the work done by conservative force depends only on the initial and the final positions, which I hope you remember from the definition of conservative force. So the potential energy also depends on the position of the object, and that is what we mean when we say that it is the energy possessed by virtue of position. Okay, because this thing is a function of position. Electronic, which college will you get? Electronics, let's see. With that rank, I think in IIT Roorkee you can get computer science dual degree or electronic, I think maybe, definitely. For a 4 year course, if you want, I don't think at 1200 you will be getting a 4 year course in IIT Delhi, Bombay, Kanpur, you won't be. Maybe Guwahati, yes, you can. Guwahati, you can definitely get. Guwahati, you can even get computer science, I think, for that rank. Okay, so you can try for IIT Roorkee or Guwahati. Okay, and maybe, of course, BHU. In BHU, you will definitely get computer science and everything, I think. Okay, so rest, you will get to know about all this in your counseling. Don't worry about it. Okay, so now let's see what is the mathematical need of defining potential energy. So most of your forces that you talk about, for instance, the force of gravity, you realize is a function of a distance. Okay, no problem. Similarly, force of electrostatic force is also a function of position, where that is distance between two charges. I hope if you have studied this, the force of gravity is G m1 m2 over r square. So it depends on the r, that is the distance between the two masses. Similarly, electrostatic force is k times q1 q2 over r square. Again depends on the distance. Similarly, if you talk about the spring force is half kx square. So you realize all these forces are dependent on your positions, right? They all have a term of r or x in them. So where you are, that determines how much force will be acting on you. So now you realize in general, most of my forces are nothing but a function of position. Now, when I'm calculating the work, by definition, dW would be FR dr, right? So when I am integrating this, you realize, I hope you realize this, if you are integrating a y which is a function of x, so when you integrate y, integral y dx, you realize you will get again another function of x only. You will get some other function of x. For instance, if y was equal to x, then integral of y is x square by 2, right? So if you integrate a function of x, you will get another function of x. I hope that is clear. If you integrated, let's say, sine theta d theta, then you would have gotten cos theta. So if you're integrating a function of theta, then you're getting a function of theta again. Okay. Thank you, I'm met. Thank you, Meet. I think Meet is your name, right? No, Pavan. KKS is not my student. I don't even know. He may have attended my lectures, but he has not been a regular student. Not that I know of, at least. Okay. So anyhow, as I was saying, so you guys will realize that here what is happening is I am integrating a function of r with respect to r. So you will realize if the limits are from r1 to r2, then what I will get is I will get some g of r after integrating f of r from r1 to r2. So which will make the answer as g of r2 minus g of r1. Okay. Now the idea is that since this work is independent of the path taken. So if imagine I am moving from position A to position B and position A has a position vector r1 and B is at r2. Right. So when I am going from A to B, doesn't matter what path I take. Now usually what will happen is whenever you are doing an integration would depend on the path. I don't know if you guys know that from your mathematics or how much integration you understand. Magnitude is same, but they are intersecting each other. Then which type of vector is this? So magnitude is same. Okay, so I don't think we actually give a special kind of name. I mean, maybe somebody has given it. We don't usually use that too much. Okay. What we use more commonly are the equal vectors, parallel vectors, negative vectors, and so on. Okay, I don't think we give a special name to that. Even if some place has mentioned a special name, we don't really use it much. Okay, Meet. Okay, so my idea is what happens is what changes when I take different paths. What changes when I take different paths? When I change different paths, my integration becomes different. I get a different integration in general. In general, that is what is happening. Okay. Okay. I don't know. It's not something too significant to have been mentioned, at most places. And I don't know. There is no common name that you use. See, what do you use commonly is your unit vectors, your orthogonal vectors. Those are terms that you commonly use. Even if there is some term about it, we don't usually use it enough for me to even remember it. Okay. So don't worry about it. Even if somebody asks you, there is no point just learning a term which you are probably never even going to use. Okay. So as I was saying, what happens when I take different paths for integration in general, mathematically what happens is that if you are integrating the same function, let's suppose if I'm integrating a function of a y which is a function of x, and if I'm integrating this, yes, exactly. So they will be non-parallel. But he wants a specific case where the magnitude should also be same. No. The magnitude should also be same. So anyhow, so suppose you have y as a function of x, and if you're integrating y, so if you take along, if you do this integration along different paths, now the only problem is I don't know if you know enough maths to understand this. That if I take different paths, let's say one path is P1 and another path is P2. So if I integrate it along P1, then I may get some g of x. Okay. If I integrate it along path P2, then usually what happens is that I will get another function. Let's say u of x. Okay. And if I integrate it along path P3, then I will get another function, let's call v of x. So in general, the result of integration depends on your path. That is in basic mathematics. Okay, you will understand that when you have studied integration in your maths class. Now, what is special about conservative forces is that since in conservative forces, you are getting the same result. Why? Because the work done is independent of the path. What does that imply? That implies a wonderful thing, that you will always get this function only. You will always get g of x only. Okay, so here also this would be equal to g of x, turns out. Even if you integrate it along path number 2, you will get gx. Even if you integrate it along path number 3, you will again get gx. See, if you get the same mathematical function, okay, see, if you're getting the same mathematical function, then you will get the same result for work. I hope you realize that. The idea of potential energy or defining potential energy was purely mathematical. Okay, so the reason why we are even talking about potential energy is that it is a mathematical idea that the work done by conservative force is independent of the path. So every time you do this integration, you are getting a function which is same for all paths, and that is why you are getting this result, work which is same. See, if you're getting the same g of r2 minus g of r1 for any path, then you're getting the same work. Now the point is, if I am getting the same function again and again, if I integrate this, then it is better for me to remember this function instead of getting this integration or doing this integration every time. Does that make sense to you? Alright, so that is what we started calling potential energy. This function, if I can just memorize this, now I can associate a function with position. You realize I can associate a mathematical function with position. So this is this value of this function at R2, this is the value of this function at R1. And if I just remember this function, if I remember the formula for this part, now all I need to do to calculate the work is find the change in this. Okay, now that mathematical function is what we are associating with potential energy. Okay, that is the entire concept of potential energy. If I just know the formula for potential energy of every force, conservative force, now for every conservative force, I don't have to integrate things anymore. All I need to do is, I know the formula, I will find the change in the value of that quantity, and that will always give me the work done. So it's just for mathematical ease that we start using this concept of potential energy. So it's just a mathematical result. Turns out when we realize, see, initially everything started mathematically. We started allotting mathematical values to kinetic energy, to potential energy, but later it turns out it is an actual physical quantity. This mathematical number is representing an actual physical quantity also. Okay, so that is how the idea of potential energy came in any case. So now you know that we had already discussed, whenever a force is doing negative work, conservative force, whenever it is doing negative work, we say that it is storing it in form of potential energy, right? Yes, so you are in class 11th, right? You will need to understand integration first. Integration, differentiation, those are important for understanding physics. So watch maybe a lecture on basic mathematics and try to study integration, small bit of integration, okay? Because trust me, that will be required. Okay, not too much. Just try and get a hang of basic integration and differentiation. Okay. So as I was saying, that we discussed this earlier, that whenever a conservative force does negative work, we say it stores it in form of potential energy. So all I can say is that delta U, the change in potential energy to move any object from position R1 to R2, is defined like this. If in going from R1 to R2, if my conservative force is doing work WC, then I can say if the work was positive, then my potential energy would have reduced by WC. And if the work was negative, then my potential energy would have increased by WC. So I can use this relation between delta U and WC. That is how we mathematically find the equation of potential energy for any conservative force, by using this relation. That whenever this guy, suppose, example, let's take an example, a conservative force does minus 5 joule work. So if it does minus 5 joule work, that means it has taken 5 joules of energy from somewhere, which it is storing as potential energy. So the stored energy corresponding to this will increase by 5 joules. So what will be your delta U? Delta U would be plus 5. So whenever a conservative force is doing this negative work, I am saying it is increasing the stored energy by 5 joules. Whatever negative work it does, whatever energy it takes out, it adds it to the already stored energy, which we are calling the potential energy. Okay. So if I use this relation, I can find the mathematical expressions for different potential energies. Okay. So here F is a conservative force responsible for the potential energy. Please remember, you can use this expression. This is very, very important. This will become the fundamental way of deriving all the potential energy expressions. So please remember, if you have a new kind of force which you've never seen before, and I tell you it is a conservative force, find the potential energy expression for that. You will always use this expression. So you don't need to remember any of the formula, by the way. You can directly calculate every potential energy equation from this. Once you have calculated this, then you can remember that, so that you can use it again and again. Okay. So potential energy is the property of a system, which I had told you last time, which is responsible for this conservative force. So for instance, every force, you realize, we studied this in Newton's laws, that every force arises from interaction between two matter. The interaction may be gravitational in nature, it may be electrostatic in nature, or some other kind of interaction. So there have to be two bodies that are interacting. So the potential energy due to this interaction is a property of both these bodies. It is not only a property of a single body. Okay. So as I said, so I already know how to find delta U. I know how to find increase in potential energy. So delta U, I know. Delta U, I know, was minus times work done by conservative force. So I can find change in potential energies. But sometimes you may be asked to find the absolute value of potential energy. How much is the stored energy? So for that, what we do is we choose a reference point. We choose a reference point which we call 0. It's something like, you can relate it to something like a coordinate system. Suppose if you had a point here and if you had a point here, and I asked you what is the difference, what is the distance between 2 points. So let's say the distance was 3. Now if I asked you what are the exact position coordinates of these, then you are free to choose a origin, a 0. Suppose you choose a 0 here. So let's take 3 for examples. Suppose I am taking I am taking 0 here, 0, 0 here. Now this probably, let's say, becomes 1, 0, and this will become 4, 0. So now you realize the actual absolute values of x coordinates in my coordinate system become 1 and 4. Right? I could have chosen the 0 somewhere else also. Maybe I decided to choose 0 here. And I could have said, okay, this would be in this coordinate system 3, 0, and this would be 7, 0. So you realize the absolute x coordinate depends on where I choose the origin. And the choice of origin is my own. I can choose an origin anywhere and give an absolute value for the x coordinate. However, does it really matter where I choose 0, 0? It doesn't. If somebody asked you, what is the distance between these 2 points? You realize that will still be 3, irrespective of what 0 I have chosen. Okay, so that is very, very important. That is why you have a choice of fixing the value of u as 0 anywhere. It is something like fixing the origin. You could have decided to fix the origin anywhere you felt like. You could have maybe even taken the origin right here. Maybe you just took the origin right here. Then this would have become 0, 0, and this would have become 3, 0. So doesn't really matter where I am taking the origin, as long as I'm talking about the distance between these 2 points, that remains the same. It is independent of your choice of coordinate system. Similarly, in most of the problems, what you want to actually find is delta U. Why? Delta U will tell you what is the work done by conservative force. So the application of the idea of potential energy is always in work energy theorem. In work energy theorem, what do you need? On one hand, you need the net work by all the forces. On other hand, you need delta K. So essentially, the idea is to find work of a conservative force. For work, you always need delta U. And delta U, I just proved to you, is independent of your choice of 0. So you can choose any reference point. So any point where you imagine or where you call the potential energy to be 0 is called a reference point. We say that this we will take as 0 and everything will be measured considering this to be 0. Okay. And that choice is completely up to you. You could choose any point as your 0 point for potential energy. Once you have fixed the 0 point, then everything can be assigned an absolute value with respect to that. For instance, in this example, as I said, if I fixed my origin here, then this can be assigned an exact coordinate. Okay, unless I have fixed a 0, I cannot assign coordinates to this. So that is the role of that reference point. Okay, so again, these are concepts which are not very simple, but if you pay close attention, if you think about it, they will make sense to you. Okay, that is why you can choose your gravitational potential energy level 0 anywhere. Doesn't matter. I will just show you examples for that. So the absolute potential energy of any object is defined as negative of work done by conservative force responsible for the potential energy to move the object from point of reference to that point. So what do I mean by that? So suppose I took a reference point and here I am saying u is 0, and suppose I want to find u at some point which is at u at r. Now what I will do is I will imagine an object being moved from here to here. And what is the work done by conservative force? Work done by conservative force, let's say, is WC. Now, by this definition, what can I say? By this definition, I can say U at R minus the initial U. The initial U is 0, should be equal to minus times WC. So, once you have fixed the 0 point or the reference point for potential energy, then you can define the absolute potential energy of any point as the amount of work minus of the amount of work required or minus of the amount of work done by the conservative force in moving a body, displacing a point object from your 0 point to the given point. Okay, I hope that definition now makes sense. Why we are using that definition. We will be using this definition a lot, by the way. You will realize later when we will study about gravitational potential energy, we will use this definition. When we talk about electrostatic potential energy, we use this definition again. That it is the amount of work required to bring anything from infinity to a given point. Why? Because there infinity is taken as the 0 reference point. So you could have taken any point as 0 reference point, and this is the logic. This is the logic which tells you that if you take a 0 reference point, then the potential energy at any position R would be minus times work done by conservative force in moving the object, displacing the object from the 0 level of potential energy to the given level. Okay. Now, let's use this and find some commonly used potential energy functions. So this also I told you last time that we talk about gravitational potential energy and spring potential energy. That is the most commonly used potential energy equations that we use in mechanics. Now, for gravitational potential energy, what we do is let's consider an example where there is a block which is kept on the ground. So what we do commonly is that we take this as the 0 level for potential energy just for ease of things. So if I take this as 0 level, and you realize if I take it above by a height h. Now let's remember that definition. U at h would be minus times work done by gravitational force. Okay, so when it is displaced from here to here, what is the work done by gravitational force? So gravity force is acting the entire way downwards. The displacement is happening upwards. So this would be minus of mg into h into minus 1. Okay, F dot S would give you minus of mgh. So you realize U at any h now becomes mgh. This is the expression that you use for your gravitational potential energy, and that is why you use mgh. It is coming from that fundamental only, from this idea. Okay. Hi Kumar, how are you? Hello Osho. So I hope that helps you understand why we use mgh. Yes, tell me Osho Rishi. Similarly, for a spring, what we usually do is that we consider the relaxed length as the 0 reference level. So where x is 0, extension is 0, this is usually considered to be u as 0. Now if I stretch it by a distance x, then let's see what is the work that would be done. So imagine at any instant, if the elongation in this spring is y, then the spring force would be backward ky. Okay, So, and you are moving it by some distance dy in the forward direction. Let's see what is the work done by spring force here. So I can say dw spring would be minus times ky dy, y minus, because ky is acting backward, and okay. So I don't know, something happened and my screen froze. But don't worry, we are back now. So as I was saying, if I wanted to identify a potential energy function for a spring, then what I need to do is I first will decide a zero level, okay, which I took at the spring extension is which where it is zero. Next, what we are doing is that from zero extension we are going to extend this spring by some x, and I'm trying to calculate the work. Okay, so let's see. So the limits of this integration would go from 0 to x, and when I do this integration I realize that work done by spring would be minus of 1 by 2 kx square. Okay, now that I have this, I know that u at x minus u at a 0, which is 0, would be minus times minus of half kx square. So you realize u at x comes out to be half kx square. So this is how I get the equation for the potential energy of a spring. Why are we getting a half kx square? This is the logic that we use. Okay. So these are the two potential energies that we will be using most commonly. So you should know the results. U at a height h here is mgh, and similarly for a spring, the potential energy at an extension of x is half kx square. Rest of the energies, when we discuss those, then we will calculate how to find that. Right now, you just need to remember these two functions. Now, what that does is that once you remember these functions, all you have to do is find the difference in potential energy, and that will always tell you the work done by gravity or the work done by spring. You don't have to do this integration again and again. So the idea is to avoid this integration again and again if you remember this result. Okay, because you will always get the same result. So now we can use the work energy theorem in a new form. So earlier you knew that net work done by all the forces is always equal to delta Ke. Now what we do is that this net work can be divided into two parts. You can write work done by non-conservative forces and work done by conservative forces is equal to delta Ke. Now, what we can also write is that work done by non-conservative forces can also be written as delta Ke minus Wc. So I take this on this side of the equation. Now I will also remember that delta U was nothing but minus times Wc. So this can be replaced by delta U, which gives this form. So this is my new form of the work energy theorem. Is the same equation. I can either say that the total work done by all the forces acting on a body is equal to the change in the kinetic energy of the body, or now I can restate that in just slightly different manner, where I will say that work done by all non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Okay, yes, this is the final form. Again, I'm not doing anything new. I have just replaced the work done by conservative forces by delta U. Okay, so it is essentially the same thing, just a new form. Now, sometimes it's not necessary that all the forces here are non-conservative only. You may have other forces also. So you can write work done by all the forces for which you haven't considered the potential energy. So non-conservative or other forces would be equal to the change in kinetic energy plus change in potential energy. Okay, so this is the new form of the work energy theorem that we arrived to, and this is again also called the work energy theorem. So this and the previous one, it's one and the same thing. Both are called work energy theorem. Okay, either you say this, so this, or you say the one in yellow. It's essentially the same thing. Both are just two different forms of work energy theorem, stating the work energy theorem. Next, the sum of the kinetic energy and the potential energy of any system is known as the total mechanical energy. So instead of object, there should be system here. Okay, so of any system, in fact, of any system is known as the total mechanical energy of the system. As I said, because potential energy is not only associated with an object, it is a property of the system. So for the entire system, you define a total mechanical energy, which is the sum of the kinetic energy and the potential energy of the constituents of that system. Okay. Now let's try and use that. Okay. So before we use that, let's just try and talk about conservation of mechanical energy also one bit. So in a special case, if there is no non-conservative force acting on your body, then, or even if there are forces, but they're not doing any work. So suppose there are some non-conservative forces, maybe also, but they're not doing any work. So in the special case when either all non-conservative forces are absent, or there might be non-conservative forces, but they're not doing any work, in that case, this left hand side of your expression becomes 0. Then you can write delta k plus delta u equals 0, which can be rewritten in the form delta k can be written as k final minus k initial, delta u can be written as u final minus u initial, and this gives you this form that k final plus k u final will be equal to k initial plus u initial. Okay, so this you can see is saying that the total mechanical energy of an object or system remains constant or conserved. See, I did not choose any particular moment to be chosen as my initial and any particular to be chosen as my final. I could have chosen any moment at my as my initial and any other moment as my final. So between any two moments, in absence of a non-conservative force, the total mechanical energy always remains constant. Or in absence of work done by non-conservative forces, the total mechanical energy of the system always remains conserved. This is called conservation of mechanical energy. Now, conservation of mechanical energy is only valid when work done by non-conservative forces is 0. So, whenever you are applying this, please check for this. I've seen students do this mistake a lot of times. There might be friction acting and they will be applying energy conservation and not getting the correct answer. So, always check to see if there is a non-conservative force which is doing work or not. If there is a non-conservative force doing work, then you use this expression. Okay, otherwise you can directly use mechanical energy conservation. So why don't we try a problem? Let's give a problem a try. So this is a problem which we solved in Newton's laws and we solved it using laws of motion, right? Now what we are going to do today is that we are going to solve this problem using our work energy theorem or conservation of mechanical energy. Let us see how to do that. So you have two masses which are hanging from a pulley as shown, and you have to find the acceleration of the two masses using conservation of mechanical energy. Let's see. So let's imagine an initial situation where you have this, you have this pulley and you have mass m1 here and you have mass m2 here. Okay, so imagine that this is the initial situation. Now in some time, let's say that this guy has gone down and it reaches here, and this guy has gone up and it reaches here. So you will realize, because they are connected with the string, if this guy has gone down by x, this guy would have gone up by x. Agreed? Similarly, if at this instant this guy is moving down with some speed v, this guy would be moving up with speed v. Okay. Now you will realize in this system, if I talk about the two masses m1 and m2, what is the external force acting on them? The external force, if I take both of them into one system, would be the force of gravity. And if you talk about the works of tension, the tension will not do any network. Why? On this guy, the tension is acting upward and this is getting displaced down by x. Similarly, on this guy, the tension is acting up and this is getting displaced up by x. So you will realize here that the work done on the system by tension is 0. So I can write, let's write it here, that since work done on the system by tension is zero, and you realize there are no other non-conservative forces that are doing work. The only force that is doing work is the force of gravity, which is a conservative force. So I can apply energy conservation here. We can apply energy conservation. We can apply conservation of mechanical energy. Okay, so in conservation of mechanical energy, what do you know? You know that the initial sum of kinetic and potential energies would be equal to the final sum of kinetic and potentials, right? So let's start writing the equations down. So let's imagine that initially it had both the masses were at rest. For the sake of simplicity, I am assuming that u was zero. So let's start writing the initial kinetic energy and the initial potential energy. And also for the sake of simplicity, I am taking this as the zero level for potential energy. U0 for gravitational potential energy. Okay, I told you I can keep the level of potential energy to be zero anywhere. So for the sake of simplicity, I'm just taking the initial height at which both the masses are as the zero level for potential energy. Okay, so Mohammad Ashraf, हिंदी में बोलूं? हिंदी में बोल सकता हूँ, but I am supposed to teach only in English. This is a JEE English channel. Okay, so this is the JEE English channel. I'm supposed to teach only in English. All right. Now all I was saying was let's start writing the initial and the final energies. So initially you realize both the masses were at rest. So what happens to my initial kinetic energy? It is zero. What about initial potential energy? That is also zero. Why? Because both the masses lie on the zero level of potential energy. Okay. So I realize K initial plus U initial is zero. Now let's write the final energies. So let's get back to the green color. So this was moving with V, this was also moving with V. This is the final situation. So final kinetic energy would be half m1v square plus half m2v square. Correct? Yes, Ashraf. So this is a new channel. What not many people know about this. So next you have the final potential energy. Also, I think it's because of the English channel that there are not many people here. So now let's write the potential energies. M2 you will realize has gone up. So M2 is x above this. So M2 will have plus M2 G x potential energy. Similarly, M1 has gone down by x from our reference level. So M1 will have minus M1 G x potential energy. Correct? Now all I need to do is use the fact that K initial plus U initial would be equal to U final plus K final. So since K final plus U final would be equal to K initial plus U initial, so now let's see what we're getting. Now I'm getting is half m1v square plus half m2v square plus m1 minus m2gx. So let's write this with a minus sign equals 0. Right? Hi Nandita, how are you? So from here what I get is that half m1 plus m2v square would be equal to m1 minus m2 g times x. Now all I need to do is differentiate both the sides with respect to time. So let's try that. Let's see what that gives us. Differentiate both sides with respect to time. Now once I do that, see, half m1 plus m2, these are constants. The only variable that is time dependent is v. So when I differentiate this, what I am getting is 1 by 2 m1 plus m2 into 2v into dv by dt. And on the other hand, I am getting m1 minus m2 times g into dx by dt. Okay. Now you will also notice one thing. What is dv by dt? dv by dt is nothing but the acceleration of the masses. And what is dx by dt? dx by dt is nothing but the speed. So from here I can write that this is 1 by 2. Okay, so this 2 and 2 will get cancelled. So I can simply write that this is m1 plus m2 into v into a being equal to m1 minus m2g into v. V will also get cancelled and you are getting your final answer as a equals m1 minus m2 over m1 plus m2g. Now you can solve this using Newton's laws. Probably it would have been easier. This particular problem would have been easier using Newton's laws, but what I wanted to show you was that you could have also solved this problem and gotten your answer without having used Newton's laws. By help of concepts of energy conservation, you can solve this problem. So that is the power of this. This work energy concepts, they are giving you an alternate tool for problem solving. Now every problem that you can solve with the help of Newton's laws, you can also solve those with the help of work energy concepts. The point is that it will require some amount of practice for you to realize that where Newton's laws are easier and where energy concepts are easier. So I have two tools in my arsenal now. Whenever I have a problem of mechanics, I can either use Newton's laws or I can use work energy power. Now I will assess the situation and see which one is easier in a particular situation. In some situations, for instance in this, you will realize that this was way easier to solve using Newton's laws. And there will be a lot of other problems where you will find the methods of work energy way easier than Newton's laws. So that is what your practice would help you with. When you practice your concepts, that will tell you which method applies better where. And that is something you have to learn by practice. There is no two ways about it. Okay. So why don't we try a practice problem then? So here is another problem. This problem would be very easy to solve using the concepts of work and energy. If you try to solve this problem with the help of Newton's laws, trust me, you will be in a lot of trouble. It would be very long, the solution. So let's talk about this. This problem tells you that a 4 kg block resting on a frictionless table is attached to a horizontal spring that has a spring constant of 400 Newton per meter. The spring originally is at its relaxed length. The spring is originally at its relaxed length and now the table is accelerated to the right with an acceleration of 5 meter per second square. So imagine this is a table. So let's say these are the wheels that the table has. Okay, and this table was kept on a ground. And on this table, this is a frictionless table, so there is no mu here. And on this, a block was kept, and initially it was kept attached to a spring which had zero elongation or compression. Now you accelerate this table in this direction with 5 meter per second square. Okay. आपको लगता है कि जैसे अनअकैडमी पर 3000 प्लस स्टूडेंट्स ऑनलाइन आते हैं, इस पर आएंगे? I don't know, maybe not. See, I am teaching on Unacademy also. I'm teaching there also, I'm teaching here also. And this channel is new, so right now maybe because a lot of people don't know about this. But yeah, probably. Or sooner or later, at least a lot of students are going to benefit from this because this content is going to be there online, right? So this is not only for today. People can watch this tomorrow also, maybe after 1 year also, people can go ahead and watch these videos and get help from them. Okay. So I don't know. I don't know how many people will come, when they will come. But it's my job to just post out videos for anybody who wants to watch. Okay. So that is the situation. I hope everybody understands this situation. This is a very interesting situation. Okay, so you have a table on which you have a block which is attached to a spring. Now you are accelerating the table. So when you are accelerating the table, part A, you have to find the maximum compression of the spring. Okay, so let's try and answer that. If you solve this problem, trust me, I will understand that you have got your concepts of work energy and application of work energy concepts figured out. Okay, so why don't you guys try this? So is you can write trying in the chat to let me know that you are trying this problem. This is a wonderful problem. Then again, as I said, if you try to solve this using Newton's laws, trust me, you will be in a lot of trouble. But with the help of work energy, you will be able to solve this very, very quickly. And again, this is another problem in which you will have to move to a non-inertial reference frame. If you can do that, and you can apply your work energy theorem in a non-inertial reference frame. I hope you remember that I talked about this. That work energy theorem can be applied in every reference frame, and in case you have to apply work energy theorem in a non-inertial reference frame, then what do? You have to add the work done by pseudo forces also. Okay, so try solving this. Try to solve this. What would be the maximum compression of the spring? And part B says if there is friction between the block and the table, with the coefficient of friction being 0.6, then what should be the minimum acceleration of the table for which the spring gets compressed? And in part C, you have been told that if the table is now accelerated with an acceleration twice as found in part B, then what will be the maximum compression of the spring? Alright guys, give it a try. Give this problem a try. This is a very, very interesting problem. And I would like to see you guys give it an honest try before I discuss this. So can I have some people trying this? Please write trying in the chat to let me know, by the way. I know, where did Pawan go? Pawan always tries all the problems. Okay. So I'm still gonna wait for like maybe a couple of minutes to see if somebody is trying this at least. If I don't see any response, maybe in the next 2 minutes or so, maybe I will just go ahead and discuss this on my own. But I would definitely like you guys to try this for a bit before I discuss the solution. See, because it's your thought process that is important. It's your understanding, and it's you who have to ultimately apply. So I want you to always give every problem a thought. Think about how you will approach this problem. Think about what you have learned. Think about how you can use what you have learned. Okay, and of course, even if you get it wrong, that is all right. I am here to correct you, and later I will tell you how to approach such problems. But I want you to give the first try. Alright guys, so try this problem, hurry up. So that is one strange thing that I've noticed, by the way, online. You guys don't want to put in any hard work. You just want to watch a video, record a video like a movie, and see, that is never going to help you much. Okay, you may understand the concepts well enough, but until unless you put in your hard work, until unless you give it a try from your end, and an honest try, a genuine try, so till then you are never getting a good result in JEE. You can't crack JEE by being lazy. You will have to put the effort, you will have to take the pain. Okay, so let's just wait maybe 1 more minute to see if somebody is trying to put that pain, take that pain. I know I can see some people online, but nobody seems to be trying. and people are coming and going. So whenever I tell people to try a problem, I see people start leaving. So I would want you guys who have stayed to try this. Okay, come on guys, try this problem. Think about this. Think about how you will solve this, how you will approach this. So this is a very very nice question, an advanced level question. So I would like to see your approach for this. So if you are trying, then trying in the chat. Otherwise, within the next 1 minute, I will start solving this. Okay. So why don't we go ahead and try and discuss the solution? So as I said, if you see in this problem, you have this table. And you have this spring, and you have this mass. So mass was 4 kg if I remember correctly, and the spring had spring constant of, so 4 kg, spring having spring constant of 400. Now you've been asked, if this is accelerated with 5 meter per second square, then what is the maximum compression in the spring? So trust me, if you try to solve this by Newton's laws, it is going to be super difficult. So what can we do then? The easiest way to solve this problem is by moving into the reference frame of the table. So that is what we are going to do first. So from the reference frame of the table, now let's analyze it. We see, let's try and figure out what we will see. So when we come in the reference frame of the table is stationary now. Okay. And you will have a pseudo force acting on our block. And how much will that be? That will be 4 into 5 Newton. So in the reference frame of the table, what you see is that the table has become stationary and there is a force of 20 Newton that is pushing this block. Okay. Now you know that if this spring gets compressed by some x, you realize after that compression, it would come to rest. See, I am already in the reference frame of the table. This block will try and compress. It will come to rest and then it will probably maybe bounce back, maybe it won't. But let's try and figure out that this force will try and push it, and eventually it will come to rest. And wherever it comes to rest, that would be the situation where it has the maximum compression. Okay, so let's try and solve this. Or maybe I could have started with an easier problem. I think I should have given you guys an easier problem, then you guys probably would have even tried this. Now I am solving this in a non-inertial reference frame. So now remember, I will use the work done by pseudo force. So since this is a non-inertial frame, we add work done by pseudo force also. In applying work energy theorem. So whenever you are applying work energy theorem in a non-inertial reference frame, then you remember to add the work done by pseudo force. So when this spring gets compressed by x, I know what is the work done by this force in this reference frame. That is 20 times x, and all this work will go into the potential energy stored in the spring, right? So from work energy theorem, I can say that 20 into x, and this will be positive, right? Because the displacement and the force are in the same direction. this would be equal to half into k into x square. This entire work, when it initially starts pressing, the mass will accelerate. Then as the spring gets compressed, the mass will start to decelerate at one point and eventually come to rest and then bounce back. This is what will happen to the mass when I push it. Okay. So when it is at the maximum compression, the kinetic energy of the mass would be zero. The entire work by this force would have gone and gotten stored in form of the potential energy stored in the spring. So from here, what do I have is that I can calculate x as 40 over 400, that is 0.1 meter. So that is going to be my answer for part number 1. Okay, so for part number 1, this is the answer that I get. I hope everybody followed this. If you have any confusion about this, then let me know. So what we did to solve this problem was we went into the reference frame of the table. We identified all the forces which had a pseudo force now, and all I did was apply the work energy theorem after considering the work done by the pseudo force also. Okay. Now that I have done that, part B is very, very simple. In part B, what have you been asked? You've been asked if there was friction. If there was friction, then what would be the minimum acceleration of the table for which the spring would get compressed? Which means if this is friction, then you realize the spring will not compress unless this pseudo force exceeds the friction value. So you will have a force which is trying to push it here, which would be equal to MA, and you will have a friction which will be trying to oppose this, and the spring will not get compressed unless MA is greater than F, right? Or limiting friction. So I can say in part B, for spring to get compressed, MA should be greater than the limiting friction, greater than equal to the limiting friction. Okay, at least it has to be just equal to the limiting friction so that it just starts to slip and it can compress the spring a bit. So from here you will realize 4 into A should be greater than equal to mu is 0.6 into M into G. M would be 4 into G would be this. So you realize the minimum acceleration. So A has to be greater than equal to 6 meter per second. So that is the answer for part number B. Okay. The acceleration for which the spring will get compressed has to be greater than 6 meter per second square. For this we got the answer as 0.1 meter. And now let's talk about the part 3. Now in part 3 it says if the table is accelerated with an acceleration twice that was found in part B. Now find the maximum compression of the spring. Yes, Osho, tell me. Why it's showing stream 9 hours ago? I don't know. Can you watch this live? You are watching this live, right? I don't know. I will find out why that is happening. That is strange. Alright, in part C now, you will realize the acceleration is double this. So acceleration would be 12. So now in the second part, if I will go to the reference frame of the table, and now I will see that there is a force, pseudo force of 12 into 4, which is trying to push it here. There is a limiting friction. So why nowadays no regular classes? Why? I have regular classes. I was live yesterday also at 4. I am live today also at 4. I have been. Oh, yesterday was Sunday. Otherwise, every day I am coming at 4. I am taking regular classes. What are you even saying? You will have a friction force which would be mu mg. So now, when this guy gets displaced, when this guy gets displaced, let's say by x. Now, all the work done by both the forces would have eventually, at maximum compression, would have gone into the potential energy. I have no idea. Yesterday was Sunday, so Sunday I never take YouTube sessions in any case, Osho. I don't take YouTube sessions on Sundays. I take it from Monday to Saturday. And I don't know where Rahul sir is. You will have to ask him. I don't know. Yes, that will be tomorrow. That will be tomorrow show. I I know. I think you have forgotten. I take class 11 sessions on Monday to Wednesdays and Fridays, and I take 12 sessions on Tuesdays, Thursdays, and Saturdays. Saturday I did take the 2021 session. Okay, so yeah, that's the time in case you didn't know. So now in case number 3, in part C, if the maximum compression is x, while it is displaced by x, there is work done by two forces. One, the pseudo force is doing work, it is doing positive work, and the friction is doing negative work. What special session? On the app, you mean? Oh, like tips and all. Okay. Okay, maybe I will plan something on Saturday, okay? I will try and plan something on Saturday. So now, if the maximum compression is x, the work done by pseudo force would be plus this into xy. The displacement is happening in this direction, the pseudo force is also in this direction. So now, applying work energy theorem, we will get that 12 into 4 into x. This is the work done by pseudo force minus work done by friction. Work done by friction would be, this is the work, this is the friction force, which is 24. 24 into x. Why with a negative sign? Because the friction is acting in this direction, displacement is happening in the opposite direction. And this is the net work done. This should be equal to half kx square. Now you realize x and x would get cancelled here, and here you have, so you have 12 into 4, that is 48, minus 24, that is 24, equals 200x, and from here you are getting your x as 0.12 meters or 12 centimeters. So that is your answer for part C. Okay, so please go through every part. Please try and see how we approach this problem, how we solve this problem. Maybe I should have started with an easier one. Okay, next time maybe I will give you a slightly easy one. I just wanted to show you, I wanted to take up a complicated one only, so that I can show you how you can solve such complex problems also, and how you can apply the work energy theorem correctly in a non-inertial reference frame. So that was my idea of choosing this question for discussion. Okay, yes, but I think now that I should have maybe started with slightly more basic problems. So no problem. For those of you who have seen this, I hope you understand what we have done in every step, how we found the answers for everything. Okay, so here was your question, this was their situation, and these are the answers that we have now. 0.12 meters. Just take a look at the solution and let me know if there is something which does not make sense to you. And if you find something like that, you let me know, I will explain that. Okay. So I guess those of you who saw the solution followed it. Because nobody at least seems to have a problem, right? What you can do is watch this later again one more time. Just go through this. This is a very uh, typical advanced level kind of problem, where you see in one question you do realize you need to know the concept of pseudo force, you need to know the concept of work friction, and you need to know the concepts of potential energy and work. So JEE, trust me, likes asking such questions which have mixed concepts. So go through this solution, try and see if you followed every bit of it, and if there was some part that you did not follow, make sure you ask me about that a day after tomorrow. Okay. So, oh yes, I had left one more page for the solution. All right, that is my time for today, guys, and I will see you next on Wednesday for this class. Make sure till then you have watched all the previous lectures also, and I would definitely encourage more live participation from you guys in the class. Before I leave, let me remind you that you should be getting your Unacademy subscriptions if you haven't gotten them already, and this is how you do it. You go to the plus section in your app, you select your goal as IIT and you click on get subscription. Now, when you are getting your subscription, you use this code RD Live. This will give you a 10% off on all your subscription fees. You can proceed. You can click on proceed to pay. This will also give you a lot of payment options with a lot of no cost EMI options, which will never make you feel the burden of this payment. Yes, it is. It is. I have started two courses on Plus also. One is starting today and another is starting tomorrow. So for 2022 aspirants, I am starting today. So 5th of October, that is where my course is starting. And for 2021 aspirants, my course starts tomorrow on Plus. These are the Plus courses. So yes, I have been planning those for a long time, and yes, finally the courses are there. They are starting from today. Okay, Anik. Alright, if you like today's video, then don't forget to press the like button and share it with as many people as possible. As I said, this channel is intended to provide free content for anybody who can't afford those subscriptions. We want more and more students to get their concepts strong, study the right way, and try and learn the right things. So make sure that you're sharing this with as many people as you can so that most and most students benefit out of this. Alright. Don't forget to press the bell icon, and the PDF notes of all the slides for use in today's lecture would be available for download very, very soon. So those of you following us on the JEE English channel, don't forget to connect with us on the Telegram app using that link. And before I leave you, remember this is my code. So if you're planning to get your Unacademy subscriptions, you can use this code and enjoy a 10% off on your subscription fees. So I will see you next on Wednesday. Till then, you guys make sure you've watched all the previous lectures. Make sure that you have followed everything that I discussed today. Make sure you have gotten some of your own practice also, so that at the start of the next lecture, you can discuss any issue that you're facing with the things that we have discussed so far. Alright then, so see you on Wednesday. Till then, you guys keep studying, keep practicing.